Assalamu alaikum. In today's video we will be solving question 1 to question number 4 of exercise 3.5. So this is skill 3.5. Let's read it carefully. Apply Venn diagrams for solving problems with both 2 and 3 sets, facilitating efficient classification and cataloging. Then apply set theory to solve real world problems, categorize products in mall efficiently, and organize music playlist by genre using set theory techniques. So these are just two examples which are given. Assalamu alaikum. So question number 1 of exercise 3.5 is consider set J is this and K is 4, 5, 6, 7. You need to determine three things: the number of elements that are only in set J, the number of elements that are only in set K, and the number of elements that are in either set J or K but not in both. So first of all, let's visualize it. Let's see that how J and K will look like. Let's say this is set J and this is set K. So you can see 1, 2, 3, 4, 5. So 4, 5 are the common elements. I can put them here. So the three elements are there, 1, 2, 3. So 4, 5, 6, 7. So only 6, 7 will come here. So after making this simple Venn diagram, I can answer all the three questions easily. I can tell that what are the number of elements in all three of them. But let's calculate them through a simple formulas or you can say identities, which will be helpful in the future also. So let's see first of all the first part. First part is the number of elements that are in only set J. So number of elements in J, this represent the total number of elements. If I put a circle here, this means the number of elements which are only in set J. It means that we are not talking about the combined elements. So as I can see from the picture clearly that the number of elements which are only in J are total 3 elements. But I need to, use a formula. So let's see. Number of elements which are only in J are basically equal to number of elements in J. This means the total elements in set J plus minus number of elements in J intersection K. So this makes sense that the total elements in set J minus the elements which are common in two sets. If we do this subtraction, we will get the elements which are only in J. So number of elements in J are 5. Number of elements which are in intersection are 2. So there are total 3 elements in which only belong to set J. So now let's solve second part. Same method. So we need to find out number of elements which are only in K. From the figure, I can easily tell you that there are 2 elements which only belong to set K. But again we will use the formula. This is equal to number of elements in set K minus number of elements in J intersection K. So number of elements in K are 4 minus 2. So you will get 2 elements in which only belong to K. So third part is really interesting. Third part is saying that the elements belong to both elements, so but not in the intersection. So there are two methods. One is, so let me call it number of elements in set A. I am taking this another set. So this is equal to number of elements which are only in J, because they are saying K, the number of elements which are only in K. So This is 3 plus 2. So a total of 5 elements. So this makes sense. There is another way. If I don't know the number of elements in J and K, so then I can say that the answer of third part would be the number of elements in J plus the number of elements in K minus the number of elements in J intersection K. That will make sense now. So number of elements in J are 5. In K there are 4 elements and you need to subtract 2. Six is the only element which is common, so I will put 6 here, and the rest of the elements of set L are 2, 4, 8 and 10. So rest of the elements of set M are 3, 9 and 12. So now it's, if I solve part 1 just like in question number 1, so I need to find out the number of elements which are exclusive to set L, so only belongs to set L. So from Venn diagram it is very clear that there are 4 elements which belong to L only, but we will solve it with a formula. So n of L minus n of L intersection M. So n of L is 5, number of elements in set L, and the number of elements in intersection is 1 only. So the answer is 4. Moving on to second part. So with the similar method, n of K, number of elements, n of M is equal to number of elements in set M minus number of elements in set L intersection M. So number of elements in set M are 4 and 1 minus, so we are having 3 elements which only belong to set M or which are exclusive to set M. So third part is the elements which are in either in set A, either in set L or set M, but not in both. So the same question just like question number 1. So number of elements, let's say I am naming the answer of set part 3 as set A. It's equal to number of elements which only belong to L plus number of elements only belong to M. So 4 plus 3, and it would be 7 elements. So you can see from the figure also 4 elements these 4 and 3 elements these. So these are the elements which belong to either set A, L or set M, but does not belong to set both of the sets. Question number 4 is Moise has 40 books in his library where 20 books are of fictional stories, 12 are books of short stories and 7 are of short fictional stories. C. So create a Venn diagram to show that the number of books of each type in the library. So first part is that you need to draw a Venn diagram, and second part is that you need to find out number of elements in A intersection B complement and number of elements in A union B complement. Also interpret the results. So let's see, let me write down the data here. So n of A, because they are calling fictional stories A, so we will use the same thing, are 20. Number of short stories are NB, which are 12. 12. So number of fictional short stories are basically given 7. So this is just to confuse you. Actually, number of short fictional stories, n of c, is basically, if you write it like this, it is n of a intersection b. It's not that it is the third category. The c is basically the common of the two short fictional stories. So understanding the question is very important. So now if you write down, and the total books are, right, this is also important, total books are 40. So now you can say that, let's say this is set A, fictional stories, this is set B, which is short stories. So these are short stories, and this A is basically fictional. So we know that the C are 7. That means that the A and B, the common area, is having 7 books. So now total number of elements are 20. So number of elements which only belong to A are basically 20 minus 7. Same method which we used in the previous questions. So in question 1n, so 13 are the books which only belong to set A. Same is the case with B. The books which only belong to short stories are basically 12 minus 7. So there are 5 of them. So this is the Venn diagram you are looking for. I hope this is clear. This is A part of this question. Now moving on to B part. So we need to find out A, number of elements in A intersection B. So number of element in A intersection B. So how many elements are there in A intersection B? We can only find complement after that. So you can see A intersection B is basically your C. So there are 7 elements in A intersection B. So now number of elements in A intersection B whole complement would be number of elements which are total minus number of elements which are in A intersection B. So we all know that the total books are 40. So we will subtract 7. So there are 37 books which are in A intersection B complement. So now second part, number of elements in A union B. So you can see that it's not given to you, but you can find out. Number of elements in A union B is basically number of elements in set A which only belong to set A plus number of elements which only belong to set B plus number of elements which belong to A intersection B. If you look at the Venn diagram, these are the elements which only belong to set A, these are elements which only belong to set B, and these are the number of books which belong to A intersection B. So the total is 13 plus 5 plus 7. So this is 25. So this is very important that you should not be using this 40 as a total. So now number of elements which belong to A union B complement would be number of elements which are there total minus number of elements which are in A union B. So basically it's 40 minus 25 and it is 15. So if I change this Venn diagram a bit, so I can do it like this, because now I know that there is a universal set also which is outside, and the rest of the books should be there. So the 15 should be here, and this is having 13 books, 7 books and 5 books. So now you can see, now there are total, this is the position of Venn diagram. 15 does not belong to any of these 3 categories. 13 belongs to only fictional, and 5 are the ones which are short stories, and 7 are basically short fictional stories. So this is the condition of this Venn diagram. So I hope you have understood it.